Hello, everyone. Good afternoon. I hope you had a good lunch. Has the conference been good so far? Okay, let's have another hour of fun. Okay, I'm Alex Thissen. This is my first time at the .NET Fest, but my third time in Kyiv. I enjoy the city very much and all the people living there. I'm an architect. When I try to explain what I do, I sometimes say I draw boxes and arrows, on whiteboards. Who of you is also considering himself an architect? Only a few of you. Oh. Good. Who thinks I'm more of a developer? Okay, so you want to see code? Yes, or just boxes and arrows? We can do everything. This session is a bit about creating .NET applications if you are making the move to container technology. And the predominant one is Docker containers at the moment. There might be others. The Docker might go away, but software virtualization and resource virtualization is some trend. So what I want to do in this session is take you on a journey with everything you know about .NET and .NET Core in particular, and see what will happen if you start making the move to containers. Now, to see for who this will be a new story. Who says, I've never gone to use Docker before, and I want to know about it? Well, you can put your hand up. Okay. So others might know. I'll go quickly over some of the things, but just to get a bit of a thing, let's say your architect or your manager says, we need to do container technology. So you get that's your application, and they say, fit it into a container. And if you don't know about it, you just see, okay, how can we do that? We just cram everything inside, and eventually it will be in there, and it will be running inside of a container. But it might not run so well. The same goes for moving your application to the cloud. The lift and shift usually doesn't work so well because the cloud does scale, but it scales your problem just as much. So all of a sudden, the small problem on-premise becomes a huge problem when you're successful in the cloud. I'll go fast at the beginning because there's a lot to cover, but when you start making the move to containers, do know that there's actually more than just Windows. I'm sure you know all about it. .NET Framework is tied to the Windows operating system. So if you want to do .NET Framework, you're stuck on Windows. But with the advent of .NET Core, and we're now at version 3.0, you can run not only on Windows Server, Nano Server, Windows Server Core, and on Windows 10 even. You can also run on all these Linux distributions. And you used to have the Mono as the port of ASPNET, not Core. But this ability to switch is a really strong thing if you make the move to container technology, because all of a sudden you can choose your underlying operating system. It doesn't have to be Windows anymore. And this affects you when you start running containers. Now this might be familiar to you. If not, that it's good to know that if you have your underlying hardware that's running the physical machine, there's an operating system on top of it. And in the case of Linux, it has this ability to run directly on top of the core, or the kernel. And it means that you don't need much. It can containerize, so isolate your application, and that's what they call a container. So you are isolated from all the others. You use a container image to get the container instance started, and you can spin up multiple of those on top of the operating system. So it uses the kernel level support for containers. And the images you make and the binaries inside, they need to know for which underlying operating system they are targeted. So no guest OS. This makes it totally different from virtualization. On Windows, there's a little bit more choice. If you start using your hardware and run an operating system on top of it, depending on which version of the operating system you have, but I'm assuming 2016 or higher, so 2019 or the more modern kernels that are there, or Windows 10 from the fall creators update and onwards. If you have those, you have multiple choices of running everything. This still applies. You can run in Windows. You can do containerization as well. It has been there from the beginning. Only recently have they made it available and usable through Docker. But that's called a Windows Server container. Now it's Windows Container because it doesn't rely on server anymore precisely. So that's the equivalent of what we just saw. But if you use the hypervisor, so that's the virtualization layer, what Microsoft offers is they have Hyper-V isolation for the containers as well. So they isolate even more, and then you run your applications on top of it in a container. And that's called a Hyper-V Windows container. And they do the same thing. If you have an operating system optimized for this scenario, then you can do Hyper-V Linux containers as well. And I think this is the future where we're going, that on Windows clusters, you can have the choice of running either Windows-based applications, like your legacy .NET framework applications, and you can have the more modern one in a mixed cluster or a mixed scenario. And you can just pick and choose and say what you want to have. So that's from Redzone 4. There's container management on the side to spin up containers, to manage your images and everything that you need. And that's what Docker did. Docker is a company, but we talk about Docker containers because they specified this standard. And it's all open source now, and it's being becoming the norm and the standard. So that's a good thing. Everybody uses the same image format for their container images. Okay, so we're about to get started. What will change in your application? Well, a lot of things will change, and some of the things won't change at all. We're going to talk about the application architecture, how you build your .NET applications. And I'll tell a little bit more about that, but these are just some of the things that you will run into if you start making that switch. So all of a sudden, environments become a thing. Where am I running? You're starting to do a composition of multiple containers working together. The configuration is a big part as well. And we will touch on most of these during this next 50 minutes. But what I do want to emphasize is this is not about application or solution architecture patterns such as CQRS, how to do microservices. That's still your choice. You can do that. But if you build whatever you're building in .NET Core, then this will show you the things that you need to change. And then you can do CQRS, event sourcing, pick your poison, and just do that. So you will start using containers. And I have a demo application that I'll use throughout to show little bits and pieces. The idea is that there's this application that keeps track of high scores of video games. Because one of my passions, when I have a little bit of time left, is I like to play old video games. So there's a front end, a web application in .NET Core, and a back end, a web API. And the idea is that you can go to the web page and view all of the high scores that are retrieved from the web API. And there should be a means of calling the web API and getting new scores in there, so they can be viewed through the website. This is what the demo application is about, but just remember that we will be talking about two containers in this case, one for the front end and one for the web API. Now, one of the biggest things that you run into is that you need a new lifecycle to get your application from your machine into production. And it's a complicated picture. Well, let's look at this one first. If you start running in containers, you want to make a distinction between running on your local machine versus later on. But if you are working locally, you can run without containers, and it should work. If you run inside of a container on your machine, it should also work. But already there's this switch. It's very fast to debug and work without containers, but the tooling is also proficient and fast, so you can even run from containers and still do debugging and have this fast cycle of writing code, checking it, doing your unit tests. It runs, okay, then we move to the next step, which is we push it out into our source control system, whatever you have, but it might be Git. And then you trigger all these pipelines. And the pipelines, they will do a build. so they will build your binaries, but they will also create this image. And this image is essential to distribute your application because everything is about this container. The container will be pushed into a registry, and that's the centralized place from which your application will be distributed to other places. And the release pipeline does the releasing of your image into the cluster, for example. So the cluster is this big thing consisting of many computers that can host your containers. One of the things you need to keep in mind, and this took me a while to get, is that the container, the image that you're making, has all of the dependencies inside. So it clicked for me when I took an old image, like a year-old image, and I thought, ooh, will this still run? Because I didn't update anything, and it's a new machine, but I still have this image. Would it run? But because everything is inside, so your binaries, your DLLs are inside, all the assemblies, and your .NET Core runtime and the framework is also inside of the image. So it's self-contained, and if you pick it up, put it on a machine that can run Docker containers, it should work. Unless the underlying kernel has such an incompatible change that you need to find a host that runs the same kernel version that your image was built on. The release pipeline, what it does is so the container isn't actually pushed into the cluster. The cluster is instructed to fetch a new image from the registry. So it's like a pull into the cluster. That's why I use the small green arrow that goes like back and forth, because it's not pushed into it, it's instructed to get it. That's your new lifecycle, and from your cluster, you want to get enough monitoring information to see how it's doing, because if there's something wrong, you want to go back to working locally again. And this is what is inside such a container. So it can be .NET Framework, you can still do that, but you need to run on Windows, make Windows-based images. But if you do .NET Core, you will have all your things inside. This is just an extract, but everything inside of your published folder for NET Core app 3.0 with everything, the list is long, that will be pushed into your image. And again, you need to make an image for your operating system. So if you want to run on Linux, then you need to make a Windows one, and otherwise you need to make a new image that's based on, well, either Windows or Linux. So that is something to do. And that is done through your Docker file. So inside of your application, in your Visual Studio, for example, you add a Docker file. It's very easy to do so. You just right-click on your project, you say add Docker support, and all of a sudden you have this Docker file that instructs how it's to be built. For those of you who would like to know that the top 4 lines that you see listed there, that's the from says, okay, I use a base image. We'll talk about that in a second. But it's as base. And it has a working directory inside of the container, and it exposes 2 ports. So that instructs the image that it's allowed to go outside over those 2 ports. This part is used for debug. So for if you're doing debug releases or debugging on your machine, they only do this stuff. And then they stop. They don't do the rest of it. It's a multi-stage file. The second part, what they do is, so the ... in between, is actually building all of your binaries using a separate image with the SDK, and they compile all your sources. And then finally, they make a lean image, taking from the base, and then the final will become everything that they build in between. And that's how the images are being built. And those images, they are layered, so you can even find those on your machine. It's different for Windows and Linux how they store it, but underneath you pick one base image. You pick the one for the operating system you're targeting. That could be Nano Server, very lean and mean, Windows Server Core if you have some more capabilities needed, or you pick your Linux distribution. Now, they all have these names, and they're stored in the Microsoft registries, so that's MCR, Microsoft Container Registry, and then they have this path-like thing with tags at the end after the colon. So 1903 is one of the latest kernels. Or you can do Debian, in this case, which has a special buster, the slim one, so everything is neat and compact. And on top of that, so we're picking the Debian one, on top of that they're building new images. These are provided by Microsoft. And you see that they have one with runtime dependencies, because on the Linux distribution, sometimes they need some SSL libraries in order to have SSL support, and then they install the runtime as well. So the runtime is everything you need from core CLR to all the framework assemblies. And then finally, they add the application layer, and that's ASP.NET 3.0, and that gives you a basis to put your stuff on top of that. So essentially, you're only adding a small layer on top of what already exists, and that is your application. So this is what you need to be building with all of your tooling. And then you go to the registry. The registry is just a place like the NuGet package feed, except it's for container images. And there's a bunch of them out there. I will show you the Azure Container Registry. But if you are on a different cloud provider, you can do that. Even Docker Hub has one, and a paid one as well, Docker Store. So you can just, but the tooling remains the same. You just push it out to the repository. And then we come to, okay, if you have such an application, you need to have a build pipeline. And all of a sudden, these things like using the .NET Core SDK with .NET as a .NET build, .NET run isn't actually used anymore, not directly. You start building your images by getting the sources and then doing multiple steps based on a composition. And again, we will talk about compositions in a bit, but the composition says this is my application, multiple containers, and each has an image, and you need to build them all for me. And the pipeline will just execute a build based on the composition, creates these images, pushes them out, and then there's this step, the third one, that says lock the service images. It actually retrieves the images again from the registry, but it has this SHA hash code inside, indicating the unique identity, and you could use that for the rest of your deployment. But one other thing to remember is, as part of your build, not only do you build the images, but you also build a deployment file. And the deployment file is the thing that you would use to actually instruct the cluster to get those new images. And that's an essential part of your build process, because it might rely on everything you've built, such as those SHA codes, for the unique identity of images. So this one pushes it out, and the lock services fetches them again and changes some things on the identity. And then the next step is that once you have those images, they're already inside of the registry. Remember the big picture with the Docker registry inside? It now has a new images stored there. And what you're doing in your release pipeline is pretty simple, because you only need to tell the cluster, get those images inside again. So one of those environments, what it has, this is the canary, and you can have early adopters, you can have many choices, you can even have development, test, acceptance, production, all the stages and environments you would like. But one of those usually has, okay, there are some secrets to be replaced in the deployment file, because you don't want to have that in code, and then you just deploy to your cluster. Kubernetes, Docker, Swarm, DCOS, Service Fabric, whatever. And that's how you actually do it. So once those images are there, you can deploy it everywhere. I'll show you that a little bit, because most of you are developers, so you want to see Visual Studio, right? Okay. This is the web API. There's a couple of things in here, and I'll put up the source code after the session. Well, there are some extra things, but what I did to get started was I said add on the project, and you can do, if you're not running, then you can see some more options. Add, you can see Docker support and container orchestrator support. So the Docker support, if you do that, if you add that, you get the, should I do this? Yes, I should. You get this option, which one are you targeting? Because the file will actually depend on it, and you get this Docker file. So remember, this is the part that is only used for debugging, and the rest is, you see that they're using an image that's called the .NET Core SDK, and then they run your .NET restore, build, and publish down here. So that's the steps they do, and that's done locally on your machine. So if you do a build, Now I'm in debug. It actually doesn't do much now. That's because everything is pre-built. Let's run it in a second. But this creates a Docker file, and you can find those Docker files, Docker images. There's quite a lot of them. But you can find them here as in the Retro Gaming Web API latest version, or the dev version. Then the other thing is that you have your Docker Compose file. The Docker Compose says, okay, we have two moving parts. Remember the two blocks in the picture of the application, the web API and the web application. And both of them have a Docker file. That's how they need to be built. This is telling the Docker composition that this is a new image that needs to be built. And we'll talk about the override later on, but there's a bunch of stuff here that actually says how it's supposed to run, such as the environments we are assuming to be running in. But with this all in place, you go to your pipeline. You have a repository here. The repository has the project, and in your pipeline, you define the pipeline like we saw in the picture. And it has all these things like the build the service images. And what it does, it uses the Docker Compose file, and that's telling the build and the build for the two images. And if you run this, in the interest of time, I won't really run it, but I'll show you the one that I did 45 minutes ago. So what it does, it goes through all of these steps and the build service images. It does all of the steps involved in the Docker file. So it says the work directory, the expose that we saw, and it just goes on and does the core SDK, and it starts building and eventually running restore and so on. So this creates a new container, and that is pushed out into the registry. So the registry is here in, let me see, there. I'm using the Azure one, but this one has repositories. It has the two images that we have, and each of these gets a tag from the build ID. So this is the unique version that we just built a couple of minutes ago, 45 minutes ago. So 248 is the latest version. You could tag this with V something, but just make them distinct, because latest is always latest, but it doesn't distinguish a new version. So if you tell the cluster, I've got a new latest, it says I already have the latest. So make sure you have unique tags instead of using latest. And then the other one is that for release. You have these environments defined, and inside of these are things to replace things into the in the deployment file, and you deploy to your cluster. And with your cluster, you have a connection to your cluster. The tooling will help you set that up, but it's a secure connection to which you can actually talk to the cluster and give it an apply command. And you say, I want to apply this deployment file. And the deployment file was created in one of the final steps inside inside this one. So the final step here is, in this case, I'm just copying out all of the YAML files to have them available. And then on a successful build, you will see that the artifacts that are published for deployment also contain your Kubernetes deployment file. So they go together with your build. New version of images, and then the Kubernetes files actually are the ones that you can use to roll out that version of your image. Okay. We've already talked a bit about your cluster, and what I can also show you is that if you add Docker support here, one of the other things you can do is add container orchestrator support. So you can choose for Kubernetes Helm, Docker Compose, which is not listed anymore, and Service Fabric. And the reason that Docker Compose is not listed anymore is because I've got this special project, Docker Compose, which allows me to spin up a composition locally. So I can still run here debug, start new instance, and I will run without a container. But with Docker Compose, firing that up, I'm actually doing a complete composition, and I'm starting up the entire application with all of its dependencies. And that's where the magic happens. See, even with debugging, and this might not be obvious, but I'm running from a container now. Yes, so going from one machine where all your containers are running to creating a fabric inside of your cluster that ties together multiple machines and even different operating systems, so you can pick and choose if you want to have Windows containers, the Hyper-V Windows, the Hyper-V Linux, or the regular ones. That's just placement constraints for your particular instances. If you have an instance of .NET Framework, you say, I want to run on Windows. So the cluster orchestrator should pick the one that is one of the Windows machines, versus if you have a Linux-based image, then you can just run on the other ones. And there's a lot of things being taken care of. I already mentioned these, that there's a whole bunch of them. Kubernetes seems to be the most popular one at the moment. There might be some shifts later on, and I'm more than happy to discuss where this is going. I think that there is a very nice future for container technology, and that in the future you might not really have to choose an orchestrator anymore. It's just abstracted away, and you can just run containers. Oh, in terms of architecture, if you have customers that tell you, oh, we don't want to have vendor lock-in on a particular cloud provider, going the container route might actually be very helpful, because you can choose, if you already have your containers, you can choose where you want to run it. So Google Kubernetes is offered by Amazon, Google, and Microsoft. The product might be different. For Azure, it's Azure Kubernetes Service. It's ECS or other types of names in all of the other providers, but they do the same thing, and your application should just run there. So if you're on the Azure and doing Microsoft mostly, just to give you an idea of all the options that you have, you can do Azure Container Service, which is an offering, a platform as a service offering that says, okay, I just want to run one or maybe a small set of containers and specify the scale, but it's not, I'm not looking for a cluster. Sorry, the Azure Container Service is actually Azure Kubernetes Service, so that's the cluster, where you can choose which ones you want to have. You have Azure Container Instance, that's the one where you have a single one, and Microsoft has tied them together with a virtual kubelet. And that means that they can use the infinite scale Azure Container Instance, because that can scale, because you don't have, that's serverless. You don't actually rent out virtual machines. But the Azure Kubernetes Service is based on virtual machines that you're using. And the Azure App Service, that's where you normally host your web applications. But if your container contains a web application or a web API, you can just tell it, I have something for you, run it from this container, and that will also work. So plenty of choice from the fact that once you have your image, you just get to choose where you run it. So composing applications. I already gave you a sneak preview on that with the Docker Compose. If you do the composition of your .NET solution, then you will make all the moving parts fit together into a big thing. So inside of your cluster, you would run everything that is designed to be run there. And that would be, for example, our front end. That would be the web APIs, and you can have multiple things of those. The front end can be an ASPNET Core, can be Angular, just hosted from there and made available through images. They will be able to call each other inside of the container cluster network. So they don't have to go outside and back in again. There's internal networking and there's outside exposure. What you don't want to do is, in most cases, do storage inside of your cluster, because containers are managed by the cluster orchestrator, and it will just kill things. And if you can only run one instance of a container, for example, SQL Server, there's a SQL Server for Linux image that you can run inside of your cluster. Microsoft has a paper out that says how to do it. But remember, it's doable, but it's not recommended for production purposes, because just think of the MDF file and the LDF file inside of SQL Server. You can do stuff, but there can only be one that has access to that. So you need one instance. If that one dies in your cluster, your database is gone. So that's why you have external resources, things that you don't want to take care of in your cluster. That could be a service bus as well, something you would typically not run inside of your cluster. But the service bus could be providing messages to a backend service that does some background work, like picking up work from the queue. And that's how you can make your application with a front end that does message-based, like CQRS, putting the commands on the queue, so it's decoupled from the backend that does the handling, high-load system. So this is a way how you could be building that. You can do caching, like Redis cache, maybe even webhooks to other places that need to respond to actions taking place in your front end. This is how you would do it, but then you come to think, oh wait, this is the picture for maybe for production, but on the test environment, I want to have it differently. In my development environment, I want to have it different, even change a couple of other things around. What I usually try to do is each of the developers in a team should be able to run their solution in complete isolation from the rest. And ideally, if you're on the bus or traveling, you should still be able to keep working, even though you don't have an internet connection or don't have all your cloud resources available. That would be good, right? So then we need to do things. Back to architecture. So what if we could run that all from our container cluster? And you can run a cluster on your laptop. That's not a big deal. I'm not sure if you know this, but if you run the Docker tooling, Docker Desktop, you actually get to have this, and let me see if I can zoom in a bit. You can actually run a Kubernetes cluster locally. It's this one, the Docker Desktop. If I switch to that one, I'm talking to my local cluster. It's a one-node cluster, but it behaves exactly like Kubernetes. So that's good stuff. Then we change things around. So all the things I said you should not be doing from your cluster, in a development or test scenario, you can choose to do it differently. And in this case, I mentioned the SQL Server on Linux. Don't do it in production, but for testing or your local machine, totally fine. If you want to use a queue as your service bus, maybe you can host it inside of your cluster. But since you can't run Azure Service Bus in your cluster, you could do something else like RabbitMQ. That's a good replacement. And Redis cache can be run from a container as well. And then you have your webhooks that will always remain external, because there could be GitHub or something where you have this webhook that you're calling from your application. Switching from calling into Azure Service Bus to RabbitMQ, you might want to do a provider pattern and do dependency injection and inject a different implementation of your message bus something in case of the production environment versus the development environment. Then you just pick the implementation. One says Service Bus, the other one says RabbitMQ. For databases, it's easy, because databases just have a different connection string, and then you're good to go. And for the webhooks, if you want to get those out, then you could do what you would probably do inside of a mixture of unit testing and integration testing, is stubbing out the external dependencies, also with injection. Just inject something else, like a fake or a stub or a mock, and that will allow you to run. And it talks to this webhook, but it's not actually doing anything. Docker Compose does that. It's part of the Docker tool stack, so you'll find that. We looked at the YAML files, briefly revisiting. You have all these services, they have names, you have the image, and some of them have the build, because it's your images and you need to build them. If it's provided images, then it just says this is the image and it's somewhere out there. You can have other things like the depends on, if you have container services depending on each other, so it knows the order in which to start them once it starts a composition. Environment, we'll talk about that a lot, is the environment variables. And then ports for mappings, the networks that you want to define, and the volumes means attached external storage inside your cluster, or maybe on your host, advanced scenarios. So with this composition, here you see the two ones that are ours, the top ones, and you see the SQL Server for Linux at the bottom. It only has an image because that's the one you will use from Microsoft. And this will build this composition where you have your web application, your web API, and SQL Server. You don't have to install SQL Server Express on your machine anymore. You can just start it. Even if you're not using all this Docker tooling, get used to running things like SQL Server from a local container outside of your application. Just spin up the container from the command line and you're good to go. So that's very easy instead of having to prep your laptop on every occasion. So the build defines a context, meaning the files that need to be copied into the image and how to do it with a Docker file. And the composition defines from a Docker Compose all the services and the images. And then you have the override, which is kind of hidden, but it's a file that gives you all of the additional stuff. The bottom one, Docker Compose, is used for the instruction on your command line, Docker Compose build. It will use that one. If you do Docker Compose up, it will go further. So let's talk about changing environments. If you go through the lifecycle, you will deploy this to many different environments. Could be development, test, acceptation, production, but could be more modern ones. But how do you go about it? So the environments, they change, but your images are not changing. And you have your connection strings and all the other things in your application settings files, but the images are immutable. So whatever you put in the image will never change. And if you deploy this one from through all of the environments, how do you change your connection string? Well, you need a couple of things, and one of the things is that you will need to use environment variables, because that's an easy way. You can influence the environment, you can't influence what's inside the image. And normally you would do Docker run and just specify all of the environment variables, and your bit of code that is there will just use the configuration and extend it out into the environment variables. This is what that looks like. You don't usually see this anymore in the more modern versions of .NET Core, because they just say create default host builder, and then it does all this stuff under the hood, but it attaches the app settings like you would normally have, but it also adds environment variables. And whatever is listed lower and it finds something with the same key, it will override what is previously defined in your app settings. So app settings is good for your local variables. As soon as you run in your composition, you would do the environment variables. So app settings, it has even, also you need to expand it in the Solution Explorer, development, production. You can name the environments and it will just pick up the right one. And essentially what this one does, it picks up the environment variables that you can specify with Docker run, but you can also provide them in the Docker Compose file. And the Docker Compose file has this section and you just name the same key value pairs. That's how you do it from the container scenario versus the non-container. That all still works. Okay, so that gives you the scenarios where you can have a different compose file or any other deployment file specifying how you would do it in a test scenario and how you would do it in production. But the Docker Compose remains the same. I'll skip over this part on configuration because I do want to talk a little bit about secrets. Once you have all this in place and you start reading your environment variables from, your environment variables from the environment, then you start noticing that everything inside of Docker is inspectable. So if you can even see this is, if you do Docker history on an image, you can see how it's being built. So if you download something over FTP or something with a username password, it will show up there. If you do a Docker inspect of a running container, it will actually show you, see the part with environment, and it says secret is sensitive, fake that, but it's readable text on your key value pairs, even though it was originally a secret. So that's kind of how do you deal with that. And this is one of the most important parts, I think, if you make the transition to containers. How do you go about it? Well, ideally, in production, you would store this in a secure place. I'm assuming cloud scenario. You can still use Azure Key Vault as an external thing from on-premises. As long as you're able to do an HTTPS connection outside, you can store stuff in a Key Vault. HashiCorp has one, Google, Amazon have them, Azure has the Key Vault. And then you can use the cluster secrets. You can actually retrieve them from the Azure Key Vault using client credentials, because you need to specify something to connect to the Key Vault. That's the key to all of the keys. Where would you leave those client credentials? Well, you shouldn't put them in your composition, because then you're exposing the key to the kingdom. Don't do that. You could do that with an application settings file, but if you just do it like that, that's not a good idea. But there's this little icon appearing. You can store secrets that are files inside of your cluster. So you need to do that manually beforehand, but that's the single action you need to do, and you can have a pipeline for that. But it's a single action that stores the key to everything into the cluster, so it's there in a secure place. On the development side, be careful what you put there, because everything you put in the JSON files or in the composition files will probably go into your Git repo and is out there. So what you can do is use the user secrets. And user secrets are inside of your application as well, but they're stored outside of the source code. I'll show that in a minute. In the Key Vault, what you would do is you would just think of each of the entries in the app settings JSON, but instead of doing the hierarchy, you do the dash dash to, you see the connection strings app config, it has dash dash, meaning that's a level below it. There's one better way of doing it, because if you have the client credentials, that works, but if you can have your application running on a certain managed identity in Azure, you're doing sort of what was the Windows integrated, except it's Azure integrated security, and you don't have any username, passwords, client ID, secrets, it's the new way. You don't have those anymore, so that's the most secure one. Okay, let's see how that would work. We can actually see that here. So normally in your startup, you would do something like this. You have your configuration, you're getting that injected, and you can take control of it, and you can do all this stuff, but most of it is already set up in this, in this create default builder. That does the app settings, the environmental app settings, that's all there. You can piggyback on that. Once the host configuration is done, you can build the configuration and start reading from it already. And then you can say, okay, I want to have these kind of things, because then I can add the Azure Key Vault as a different place to store my secrets and my environment variables, because they will show up as configuration in the end. So I should be careful there. It's configuration variables, but they come from Key Vault. Where do these come from? Well, in the case of locally, I would just do manage user secrets, and they're here. See, Key Vault, client secret, and ID. I will change those, so those quick to note won't be valid very long. But those user secrets are stored somewhere else, not inside of the source code, but they are added if you are running a development environment. And then if it's not environment, not development, we're adding the Key Vault, and then you can do other stuff and start reading from it. So that's the way to do it. And here you can have the Key Vault, which is pretty simple. You have keys, secrets, and certificates, but the secrets are key value pairs, and you can just have multiple versions of it and withdraw them or delete them. Okay. Because we are running out of time, let me quickly go with, okay, so we're doing it securely. We have a composition, so everything is running and it can talk to each other inside of the composition. And then you find out that the cluster orchestrator is actually pretty merciless. It will kill pods or containers if they're not behaving. So there's this pets versus cattle. Read up on that. It's pretty brutal how the container orchestrator, if it's in doubt, it says, okay, you container, go away, and I will spin up a new one. So containers might come and go. Cloud resources might be intermittent, so they might have glitches like a second of unavailability. And you need to take that into account. Mostly you will have connections from your front end to your back end, so there's types of connections. HTTP, data connections using different protocols, message queues, or tabular data streams for SQL Server. But they will go away and they might not be available. So that can be broken there, or everywhere. That's usually a bad sign. And that's why you want to have cloud patterns like retry, timeout, fallback, bulkhead, circuit breaker. And most of the Azure stuff has NuGet packages that already provide those capabilities. So you just have to configure it and it will take care of it. For example, SQL Server, you can just say, if you attach your Entity Framework core, you can just say use SQL Server with the enable retry on failure, and it will start doing all this retry based on the configuration that you specified. But if you're doing the HTTPS, you're kind of out of luck. The cluster will, okay, so HTTP, if you do those calls, then you need to do something else. And I think the preferred library at the moment is Poly. Microsoft uses it internally as well. But there you can specify policies to do each of those patterns, like retry, fallback, circuit breaker. And they neatly integrated this into .NET Core because they have extensions based on Poly where you can say, okay, if any part of my system has the web app calling the web API and I need an HTTP client there, I'm using the HTTP client factory and I'm attaching Poly behaviors for how to do the patterns on top of that HTTP client. And then it takes care of that. Whenever you ask for a client, it will have everything behind it, including the Poly behavior. And now I need to rush a little bit because I saw we only had 5 minutes and that was 2 minutes ago. So we have the web API, we have the front end. I'm using refit, this library here, to do a trick. I'm calling the web APIs based on a C# interface. So this defines the shape of my GET request in this case. This is the relative URL, this is the signature, it expects a parameter, and it returns this. And based on that, I can specify in my startup that when I'm defining all my dependency injection services, I do add HTTP client with timeouts on the HTTP client itself. But I'm also attaching Poly behaviors that also has timeouts. So you have the connection timeout and you have the time that you as an application are willing to wait. And that it does transient HTTP errors. So transient means it might go away errors. Retrying 3 times and then saying, okay, add this typed client. This is refit. Whenever I ask for iLeaderboard client, which is the interface, I'm getting this typed client, this thing made by this code that has an HTTP client inside and all the policies wrapped around it. And when I use it from a page, I'm simply injecting this leaderboard client instance, but it will have this typed client. And the typed client, you can just say, okay, do get high scores, and it will do everything, including the retry policies and such. So this is a neat way, clean way to not have it all in your implementations, but this is just an interface and you're calling into the interface, but all the magic happens outside. Running out of time. Okay, the final thing I would like to add is that on service, if you have this behavior of retries and stuff, it's slowly getting into the layer of the orchestrator. So you have these service meshes that also take care of reliability offerings. You might want to check those out. Istio is a popular one, Console and Linkerd version 2. Those 3 add stuff into your cluster that make that work. Oh boy. I'll give you the slide. So the things that we weren't able to cover. The final thing is about health. that's the last part that you would need to do, that you are exposing health endpoints. Because if you're running in a cluster and you want to offer your orchestrator the ability to ask you how well are you doing, you should be able, as a web API or a web app, to just say, okay, this is how I'm doing. And it's available since .NET Core 2.2. You can do multiple checks from SQL Server, external sources, or your service buses, anything, just adding these health checks and exposing them to the outside world. Then you can actually indicate, if my database is not available, I'm not being healthy, so maybe you should kill me, because it might restore itself. Yeah, merciless, like I said. There's a way to do that inside of your composition files, where you actually give this ready and lively endpoints, saying I'm ready to receive and I'm still alive. Yes, so I think we're out of time, are we?
We have 5 minutes for questions.
Okay. Questions or the final demo on rolling updates? And questions can be done afterwards, so what do you say? Demo, okay. So, good answer. If you have that in place, what you can do is a zero downtime deployment for your cluster with your fancy .NET Core application. What it says here is we have 3 replicas. This is Kubernetes, so they have pods. Pods are the containers. Could be more than one inside, but just say a pod is a container. 3 of them means we have 3 running on different nodes, so if one crashes, your application doesn't go down. If we do a rolling update strategy, we say, okay, you can only add 2 more, because we don't want to bloat during a rollout of a new version. We need to have the old ones and the new ones side by side, so we can quickly slowly move over to the new ones. But only 2 extra, and you can never have under 3 available. So no unavailables. So what it does, it says, okay, go add this one, add another one, because we could search with 2 extra. Then it waits for them to become ready. And once they're ready, they'll go green. Then we can take one out. We can spin up a new one, because we need to replace all 3 of them, and see that it's pod V1 and V2 appearing. Then the other ones go up on green, so they can take out the V1 versions, and all of a sudden we have an upgrade. But we never lost the original ones, and we only replaced them once the new one was ready to go. Now, let's see if we can quickly demonstrate that. Okay, what I did is, and you'll have to believe this, I have this file, this one, and I'm deploying a new version, 2.4.8. This is the file that I'm doing there, and I'm applying it now, so that's a new version. Now let's hope that this one is available, because so all was green, but now it says, okay, we've got a new replica set coming up. We're adding 2 extra ones, so the new replica set is actually not doing very well, because it's not ready yet. See, red. And this is now querying that health endpoint and asking it, are you ready or not? And once they become ready, and it takes a little while, you see we still have the original ones that are an hour old, but now we're replacing them with the new version. And slowly you see that some of them are actually starting to behave better. So we have one new one that's running 37 seconds ago, and more are becoming available. So we have the new version running here. All of these new ones are actually already replaced. And then finally, and this might just take a little bit extra, there should be the latest one replaced as well. The first one is already replaced. It didn't have the update strategy, so that would always work. And now we have 3 new ones that are under a minute old. It's still, there's 1 too many, so probably 1 is going to die, see, 20%. And then after that, it's all green again, and we have a rolling update, because we added the code that did all the health checks. Here. This is the code that you need to do to add the health checks. So it says, get me health checks for ready, for lively, and put it on management port so it's not available from the outside. That is the new way to get your application, your .NET application, to play nice in this Docker ecosystem. So we ran out of time, but thanks very much for your patience.